Hello students, today we are going to see the Laplace transform of x of t equal to t u of t. Generally, the Laplace transform formula is given by Laplace transform of x of t is x of s, which is nothing but minus infinite to infinite x of t e power minus st dt. So here our problem x of t is t u of t. We know that u of t value is 1 for t greater than or equal to 0 and it is 0 for t less than 0. So I can write x of t as t into 1 because u of t value is 1 and but 1 exists only for what? T greater than or equal to 0, right? So t into 1 is nothing but t. So x of t I can write this is t, but this value exists only for positive values of t, that is t greater than or equal to 0. So using this, let us substitute in the general formula of Laplace transformation. So Laplace of x of t, here it is, since x of t exists only for t greater than or equal to 0, that is t varies from 0 to infinity. So I can rechange the limit minus infinity to infinity as 0 to infinity. Why? Because this problem x of t exists for t greater than or equal to 0 and x of t value is t into e power minus st dt. So now let us integrate this value. So while integrating, we have to use u dv formula. So integral u dv formula is uv minus u dash v1. So here in this problem, this value, that is t, is nothing but u, this value is nothing but dv. Okay, so using that, u is t and dv is e power minus st dt. So in the formula we need to apply the value of v. So let us find out v. So integrate this term, right? E power minus t, integrate this, we will get v. So v is nothing but e power minus st by minus s. Again v1 is, one more time we have to integrate this value. So v1 is, so already I have constant 1 by minus s, keep it aside. Integrate e power minus st, again e power minus st by minus s. Okay, so these two values are there. So v1 is e power minus st by s square, minus into minus is plus, s into s is s square. Okay, and u dash I need to find out. U dash is, I have to differentiate this value. So differentiation of t is nothing but 1. So using this I can apply in the given integration. Okay, so I have to write first u. U is nothing but t and then v. V is e power minus st by minus s. Okay, so this is uv term minus u dash. U dash is 1 and v1. V1 is e power minus st by s square. Okay, so here generally we have integration, we have this formula, but here there is a apply the limits in both the terms. So 0 to infinity we have to apply the limits. Okay, so let us apply the upper limit. Wherever I have t, I have to replace it by upper limit infinity. So infinity into e power minus s into infinity divided by minus s. Apply the lower limit. So minus into minus will become plus. T value is 0, 0 into any value, definitely it is 0. Okay, so leave that and then minus, apply the upper limit. Okay, e power minus s into infinity divided by s square. Okay, and then apply the lower limit. For applying the lower limit we have to use one minus. Okay, so e power minus s into 0 divided by s square. Okay, so anyway this is infinity, but this value, what is this value? S into infinity is infinity. Okay, so we have the formula, right? I will write here, e power minus infinity. What is e power minus infinity? 0. Okay, so this term completely becomes 0. Okay, similarly this term also, s into infinity is infinity, e power minus infinity is 0, so this term also becomes 0. Okay, already second term is 0, so first term, second term, third term is 0. Okay, so minus into minus is plus, so plus e power 0. What is e power 0? E power 0 is 1. Okay, so e power 0 is 1, so it is 1 by s square. Okay, so Laplace of t u of t is 1 by s square. This is the final answer. Okay, thank you. Thanks for watching.